In this video, I'll walk you step by step through building a high-end Aero road bike around the Factor Ostro VAM V2. We'll cover everything from start to finish, including internal routing, drivetrain installation, Di2 setup, brake bleeding, and final tuning. I'll also put links to all the major parts and tools I use down in the description if you want to follow along or reference anything in your own build. Along the way, I'll also 3D print a custom headset cover to match the bar and stem combo to the frame. To start, let's take a closer look at the frame. This is the Factor Ostro VAM V2. I chose this frame because it's designed to be lightweight while still maintaining a strong aerodynamic performance. I'm building this bike from the frame up. For this build, I'm mixing Shimano Ultegra and Dura-Ace Di2 components, installing a custom 3D printed headset spacer that I designed myself, and running a set of BTLOS carbon wheels that I've been riding lately. Let's get started. Usually, the first thing I do is route the Di2 cables. Normally, the battery sits inside the seat post, which means I can't mount the frame in the bike stand until all the cables are routed. But on this frame, there's actually a dedicated Di2 battery holder right behind the bottom bracket, so I can install the seat post first and still route the wires later. It's not groundbreaking, but it's a nice touch. As seat posts have gotten more aero, the batteries don't fit inside anymore. It also eliminates the extra wire length you'd normally need to remove the seat post. The seat post slides into the frame with a little bit of carbon assembly paste to keep it from slipping. Then a small aluminum plate is installed behind the seat post, and two small set screws compress the plate against the post to hold it in place. It doesn't make for the cleanest look behind the seat post, but it does provide easy access and avoids having a wedge bolt at an awkward angle, which can be annoying to deal with. Now that the seat post is installed, I can clamp the frame into the bike stand and start installing the brake hoses and Di2 cables. I started with the rear brake hose. From the back of the bike, I fed the hose through the rear brake port on the chainstay and pushed it towards the bottom bracket. With a little twisting, I was able to feel it come through the bottom bracket area and guide it up towards the head tube. Once it came out at the top of the head tube, I installed the rubber sleeve on the brake hose, which prevents rattling when riding on rough roads. Next, I moved on to the Di2 cables. I first tried pushing the cable for the rear derailleur from the rear of the bike towards the bottom bracket, but there wasn't enough column strength to push it through without bunching up. The newer 12-speed Di2 cables are thinner, so they don't guide quite as easily, but the upside is they take up less space inside the frame. In the end, I taped the Di2 cable to a derailleur cable and used it to guide it through the frame. Because the battery sits right behind the bottom bracket, the front derailleur Di2 cable can be very short, which makes the installation pretty easy. I installed the cable and plugged both wires into the battery. Then, I inserted the battery into the frame, making sure it didn't get tangled with the brake hose, and secured it with two mounting bolts. Next, I installed the rear derailleur. This can be done later, but it's nice to connect the Di2 cable now so it doesn't fall back into the frame and force me to route it again. I did the same thing with the front derailleur and installed it early as well. I mounted it lightly to the frame and positioned it a little higher than normal so I could install the crankset. After the crankset is installed, I'll lower it back down and adjust it properly. Next, I moved to the back of the bike to attach the brake hose to the caliper. I inserted the barb into the brake hose, then installed the olive and the compression bolt before tightening the brake hose to the caliper. After that, I mounted the brake caliper lightly to the frame since it will be adjusted later. With that done, I moved on to prepping the fork. I didn't film routing the brake hose through the fork, but it was really easy. I just pushed the hose into the port and it came right out through the opening in the middle of the steer tube. No fishing around with a flashlight and all. Once the hose was routed, I lightly mounted the front brake caliper to the fork using the 2 bolts since it will be adjusted later. Before installing the fork, I wanted to show you how I created a custom headset spacer to work with the Tevelo Arvo bar stem combo. I started by taking a photo of the underside of the spacer that comes with the Factor frame and traced the outer profile as well as the opening for the fork. On another plane, I used a reference photo to trace the shape of the spacer used with the Tevelo bar and stem. From there, I created a loft between the 2 sketches, which forms a smooth transition between the 2 profiles. After that, I made a few small adjustments, cleaned up some of the edges, and then 3D printed the part. I printed it in a material called ASA, which has good strength but also handles heat and UV exposure well since the bike will spend time out in the sun. It took a few iterations to get the fit just right, but I think it came out pretty well. Now back to installing the fork and handlebars. Since the brake hoses are already routed through the frame and fork, that part is taken care of first. Next, I apply grease to the headset bearings and the bearing contact surfaces. With these fully internally routed frames, it could be much harder to access the bearings later for cleaning and re-greasing, so it's good to protect them well from the start. I began by installing the lower headset bearing onto the fork, then carefully inserted the fork into the frame. After that, I installed the upper bearing. Both brake hoses passed through it and then through the custom 3D printed spacer. From there, I routed the brake hoses through the handlebars. The rear usually goes on the right side and the front on the left, but it ultimately comes down to personal preference. Routing hoses through integrated bar and stem setups is one of my least favorite parts of any build. This Tevelo Arvo bar has some tight bends and a fairly small opening near the shifters, which made it a bit more challenging than some, but still manageable. One tip that helps is to put a slight bend at the end of the hose. That allows you to rotate and guide it towards the opening. Once it gets close, I use an angled awl to help fish it out. Once both hoses were routed through the bar, I lowered the stem and handlebar assembly onto the fork while gently pulling the hoses to remove any slack. Next, I moved on to installing the shifters and preparing for the brake bleed. I started with the first shifter and positioned it on the handlebar roughly where I thought it would end up. This gave me a good reference point to measure the correct brake hose length. Once I had the position set, I cut the hose, then removed the shifter. It's much easier to install the barb, olive, and compression bolt with the shifter off the handlebar. While it can be tightened with the shifter still mounted, the clearance is very tight and there's a risk of scratching the carbon handlebar with the wrench. After attaching the hose, I reinstalled the shifter and lightly tightened it into position so I could fine-tune the setup later. I then repeated the same process on the other side. With brake hoses cut and installed, the next step was bleeding the brakes. We'll start with the rear brake. First, I remove the brake pads and install a bleed block into the caliper. Next, I move up to the right shifter and install the bleed funnel at the top of the lever under the hood. Then I prep a bleed syringe with fresh mineral oil and attach the hose to the caliper. I open up the bleed valve and begin pushing new fluid through the system to remove any air bubbles. I continue to push fluid until I no longer see bubbles coming up through the funnel. Once the bubbles stop, I close the bleed valve at the caliper. After that, I pull the brake lever a few times to help release any remaining air trapped in the lever. I like to do this at different angles to make sure all the bubbles are removed. Once I'm satisfied, I insert the stopper into the funnel and remove it from the lever, then install the bleed port cap. I move back to the caliper, remove the bleed block, clean any excess fluid, and reinstall the brake pads. I then repeat the same process for the front brake. With the brakes finished, I moved on to setting up the wheel set. Before installing the wheels, I wanted to talk briefly about them. I have no affiliation with BTLOS, but I've been really happy with this wheel set over the past few months. They're super light, coming in at around 1,290 grams, but still have enough aero depth to work well on just about any bike. For me, that means there's really no need to choose between a climbing wheel set and an aero wheel set. One thing I really like is that you can customize nearly every component. For this build, I chose the Aerox Pro Series at 52mm depth with a 23mm internal width paired with DT 350 hubs and Supreme CX-ray spokes. I also appreciate that they offer a no decal option for a more stealth look. Looks aside, the biggest things I've noticed is how balanced they feel between weight, stiffness, and aero performance. For me, 52mm has been the sweet spot. You get the aero benefits without being as affected by crosswinds. With that covered, I've moved back to setting up the wheels. I've been running these tubeless with 30mm Continental Archetype tires. They're slightly lighter than the Continental STR tires, with some trade-off in durability from what I've heard, but so far I haven't had any punctures and they've worked well for the type of riding I've been doing. I started with the rear wheel and installed the cassette. One tip is that there's a small arrow on the smaller cogs that helps line them up correctly during installation. Next, I installed the Dura-Ace rotors. There's no real weight difference between Ultegra and Dura-Ace rotors, but I found these at a good price. I've been running a 160mm rotor on the front and 140mm on the rear, which has provided me more than enough braking power for my riding. With the wheels ready, I moved on to installing the bottom bracket and crankset. The Factor Ostro VAM V2 uses a T47A asymmetric bottom bracket standard. Since I'm running a Quark D4 power meter crankset, I installed a SRAM dub bottom bracket. Once the bottom bracket was threaded in and torqued to spec, I added a 3mm dub spacer on the drive side according to the SRAM dub chart. Remember to loosen the preload adjuster on the non-drive side before torquing down the crankset. After the crankset is fully tightened, you could then set the preload. Tighten the preload adjuster by hand until all side-to-side play is removed, but the crank still spins smoothly. At this point, I installed the pedals. You could wait until later, but installing the pedals now makes it easier for them to rotate the drivetrain while setting up the derailleurs. Always remember that the right pedal tightens normally and the left pedal is reverse threaded. One way I keep this straight is by placing the wrench vertically behind the pedal and turning it towards the front of the bike to tighten. With the crankset installed, this is a good time to set up the front derailleur. I start by setting the front derailleur height. Then, I rotate it so the tail sits slightly closer to the frame, then tighten the mounting bolt down. After that, I use the adjustment screw to push it outward until it aligns with the outer chainring. After that, I use the support bolt to push the derailleur outward until it lines up properly with the outer chainring. Sorry I didn't show this step in the video, but once that's set, the derailleur position is basically dialed in. I then installed the rear wheel so I could set the correct chain length. Before setting the chain length, I adjusted the rear brake caliper since it was rubbing. It's easier to take care of this now before moving further in the drivetrain setup. Next, I installed the chain using Shimano's recommended method. I laid the chain over the largest chainring and largest rear cog without routing it through the derailleurs, then cut the chain to the correct length. Once the chain was cut, I routed it through the derailleurs and connected it using the quick link. After installing the chain, the next step is syncing the derailleurs with the shifters. To start the pairing process, I press the button on the rear derailleur until I see a blinking blue light. Then I open the Shimano eTube app on my phone and tap the Connect Bike button. The rear derailleur should appear on the screen, and once I select it, the app begins connecting. At this point, it may ask if you want to change the passkey. You could do it now or later. If you don't know the passkey, the default is usually 000000. Once connected, I confirm the detected components. In this case, the system still shows the previous shifters, so I need to update that. I scroll down to Add or Remove Wireless Switch, then select the option and unpair the existing shifters. After that, I tap the barcode icon and use the camera to scan the barcode located inside each shifter one at a time. Once both are scanned, the shifters are successfully synced with the derailleurs. Then I could press the disconnect button. Next, I moved on to indexing the rear derailleur. I start by setting the high limit screw to make sure the chain won't overshift off the smallest cog. Then I shift into the largest rear cog and set the low limit screw. While I'm there, I also adjust the B tension screw to ensure proper pulley clearance from the cassette. After that, I shift into a cog somewhere near the middle of the cassette to begin fine-tuning the indexing. To enter adjustment mode, I press and hold the button on the rear derailleur until the light turns yellow. Once in adjustment mode, I use the right shifter to move the derailleur slightly left or right with each click until it lines up perfectly behind the selected cog. After making small adjustments and checking shifting performance across all gears, the rear derailleur setup is complete. From there, I move on to dialing in the front derailleur. Since we already aligned the height and the angle of the front derailleur earlier, I'll start by setting the low limit. First, shift into the smallest chainring and the largest rear cog. Then, press the button on the rear derailleur until the light turns yellow to enter adjustment mode. From there, use the left shifter to move the front derailleur slightly in or out until the inner cage is as close to the chain as possible without rubbing. Once it's close, I usually move it a couple clicks outward to give a little extra clearance, since pedaling can induce some frame flex. Next, shift into the large chainring and the smallest rear cog, then enter adjustment mode again. Adjust the front derailleur so the outer cage sits as close to the chain as possible without rubbing. I typically leave a bit more clearance here since the gear combination can see higher torque loads. Then, while still in the large chainring, shift into the largest rear cog to check cross-chain clearance. Enter adjustment mode once again and fine-tune the derailleur position until there's no rubbing on either side of the chain. Finally, run through the front shifts across different rear gear combinations to make sure everything is smooth. Once shifting feels consistent, the front derailleur setup is complete. Now I can move to the front of the bike and install the front wheel and adjust the front brake caliper. After tightening down the front through axle, I loosen the brake caliper mounting bolts so the caliper can move slightly. I check to make sure the caliper is able to slide freely, then pull slowly on the brake lever until the pads make contact with the rotor. While holding the brake lever down, I tighten both mounting bolts. This centers the caliper automatically over the rotor. Once the bolts are tightened, I release the brake lever and check to make sure there's no rubbing and there's even clearance on both sides of the rotor. At this point, I'll spin the wheel a few times and apply the brake a few times to confirm everything is aligned properly and functioning smoothly. With the front brake centered and working correctly, the front end of the bike is now fully set up and ready for the remaining components. Now I move on to installing the saddle. I loosen the clamp, slide the saddle rails into place, and lightly tighten it down. Once the bike is fully assembled, I'll set the final saddle angle and fore-aft position on flat ground. To finish off the build, I move to the handlebars and wrap the bar tape. It's a good idea to put the bike on flat ground first so you could set the shifter position exactly where you want it before wrapping. Small adjustments can be made later, but if you move them too much, you'll end up needing to redo the tape. When I wrap, I start underneath the bar and work towards the outside of the bike before coming back over the top. There are different opinions on wrapping direction, but I've always preferred this method. When I'm sprinting out of the saddle, my hands naturally rotate inward, and this wrapping direction helps keep the tape tight rather than loosening. As I'm wrapping, I try to keep each pass overlapping the previous one by the same amount so that the tape looks consistent from end to end. When I reach the shifter, I usually skip the extra finishing strip and instead use a figure 8 wrap, which I think results in a cleaner look. As I get near the top and need to make the final cut, I align the tape in the same direction I've been wrapping and cut along that line. This usually results in a clean, smooth finish. Then I repeat the exact same process on the other side, making sure to match the overlap so both sides look balanced and consistent. Once the bar tape is finished, the build is essentially complete. At this point, I'll make the final saddle height and angle adjustments, install the bottle cage, and go back through the bike to double check all the main bolts to make sure everything is properly torqued. With everything set, it's time to see where the final weight came in. On the scale, this build comes in at 16 pounds 3 ounces for a 54 centimeter, which I'm really happy with considering the balance between aerodynamics, weight, and overall ride performance. After putting some miles on the bike, I've been really impressed. It has the responsiveness of a true climbing bike while still feeling fast and efficient on the flats. If you're building a bike like this, I hope this walkthrough was helpful. Most of the process is very similar across modern bikes with just a few small differences depending on the frame and components. I've included links to the main parts and tools I use down in the description if you want to reference anything from this build. Thanks for watching, and I'll see you in the next one.